Good afternoon, everyone. So I'll be discussing simplex method maximization. As mentioned during the lecture, you can use graphical when you're solving two variables only. But for simplex, you'll be able to solve two or more variables. So the following are the steps in solving simplex method. The same thing with graphical, you have to set up the initial solution and formulate the LP model. So I use the same example as what we have in the graphical maximization. So the objective function is to maximize the total profit, which is equal to 8x1 plus 6x2, subject to the following constraints: the assembly and finishing. 4x1 plus 2x2 is less than or equal to 60, and finishing is 2x1 plus 4x2 is less than or equal to 48. And the non-negativity constraint, which is x1 and x2 should be greater than or equal to 0. Okay, so during the graphical, we only have two variables, but in simplex, we'll be introducing additional variables. So if you try to look, the sign that we have in the constraint is less than or equal to. So if the sign is less than or equal to, you have to add slack variables. So the slack variables depends on the number of constraints, not on the number of decision variables that you're looking. So in this case, you'll have slack variable in the assembly and slack variable in finishing. Okay, so what is this slack variable? These slack variables are the unused time in the assembly for SA and the unused time in finishing. Okay, that is SF. You can also write down S1 or S2 if you want, just as long as you get the right answer. So therefore, from the old equation that we will have a new equation, which is 4x1 plus 2x2 plus slack variable in the assembly is equal to 60. So we can equate it now into 60 because we added the unused time in the assembly. The same manner in the finishing, we will have 2x1 plus 4x2 plus slack variable in finishing is equal to 48. So the final form will be your objective function. It is equal to 8. The profit is equal to 8x1 plus 6x2 plus 0 SA plus 0 SF. All the slacks variable doesn't have any value or doesn't have any profit at all. That's why it's 0. Subject to the following constraints, we just copy the one that we written on this one. We just copy it, but we write down if we have value in SA. Of course, we don't have any value in SF because it's assembly. The same manner in finishing, we don't have any value for the slacks in assembly, but we have value in SF. Okay, so it is equal to 60 and 48 respectively. And of course, the non-negativity constraint, which is all the variables that we have, x1 and x2, and the slack variable in assembly and finishing should be greater than or equal to 0. So it's not possible for us to have a negative value. Okay, so in writing down the initial tableau, this is what it will look like. So CJ is the profit per unit. That's why if you try to look horizontally, you have 8, 6, 0, and 0. Okay, and then you write down the production mix, the quantity, your variable, which is x1, x2, SA, and SF. You just copy all the variables that you have in the equation. Okay, So initially, the product mix will be SA and SF. And as you go on with the tableau, it will be changed into the variables that you're looking, which is X1 and X2. Okay, so again, your CJ, the profit per unit, if you have slack variable in assembly is 0, and for slack variable in finishing it's also 0. And then just copy all the coefficient of the numbers in your equation. So these are all the numbers: the 6048, 4210, 2401. So it's the same value that you have in here. Okay, so what is CJ? CJ is the total profit. How are we going to compute it? The CJ multiplied by the value that you have here, which is 4, plus the CJ of SF multiplied by 2. So all numbers multiplied by 0 is 0. The same thing here, it's also 0. Why? 0 times 2 plus 0 times 4 is 0. The next one, 0 times 1 plus 0 times 0 is 0. And again, this one is 0. And then the ZJ minus AJ, which is the profit per unit minus the total profit, you'll have here the profit per unit is 8 minus 0 is 8. 6 minus 0 is 6. 0 minus 0 is 0. And 0 minus 0 is 0. Okay. You get the next step will be you get the highest positive value of CJ minus AJ, which is this one. The highest positive is 8 compared to 6, 0, and 0. So you choose 8. So this is the optimal column. What does it mean? It means if you're going to change the value of x1 to any of this variable, the slack variable that you have, you will be getting the highest profit. So after getting the optimal column, which is the highest positive of CJ minus AJ, you divide the value of quantity with the intersectional element of the optimal column. So we have 60 over 4 and 48 over 2. 60 over 4 and 48 over 2. So between the two, 60 over 4 is equal to 15 and 48 over 2 is 24. The replaced row should be the lowest positive. Okay? So between 15 and 24, 15 is the lowest positive. So this will be your replace row. The row wherein you have slack variable in the assembly. Okay. So now what will be the next step? You have to compute for the new value of your x1. The x1 value that you have here for the optimal column will replace SA in the replaced row for the variables. That's why you have new value of x1. How are you going to compute it? The intersectional element, between the optimal column and the replace row, which is 4, will be the denominator. So we will have 60 over 4, 40 over 4, 2 over 4, 1 over 4, and 0 over 4. Okay? So that will be the new value of x1. So you have 15, 1, 0.5, 0.25, and 0. And the new value of SF, so it was not replaced, but you're going to compute for the new value. It is equal to the unused row value of SF minus the intersectional element of the unused row and the replaced row. So meaning you have 48, 2, 4, 0, and 1. You have 48, 2, 4, 0, and 1 minus the intersectional element, which is 2, between the optimal column and the SF. So you have 2 intersectional element. and then the replaced row, which is 15, 1, 0.5, 0.25, and 0. Yan, dyan galing yan. Okay? And then you have the value for SF will be 18, 0, 3, negative 0.5, and 1. Okay. Afterwards, you're going to plot it again in the second tableau. So, same format as you have, but instead of SA, you'll have the new value of X1. So, you have to copy 15, 1, 0.5, 0.25, and 0. What is the profit per unit for X1? If you try to look at the equation that we have for X1, we have $8 per unit. Okay, that's why you have 8 here. And again, you just copy the new value of SF that you have computed. So you have 18, 0, 3, 0. Negative 0.5, and 1. The profit per unit for SF is 0. So when you try to compute now for CJ, which is 8 times 15 plus 0 times 18, it is equal to 120. The same thing for the X1 row, we have 8 times 1 plus 0 times 0. That's why you have 8 here. And 8 times 0.5 plus 0 times 3 is 4. And then 8 times 0.25 plus 0 times negative 0.5 is 2. And the last one is 8 multiplied by 0 plus 0 multiplied by 1 is 0. Okay, so now we're going to subtract CJ, which is 8, 6, 0, and 0, minus the CJ value that we have computed. Okay, so we have 8 minus 8 is 0, 6 minus 4 is 2, 0 minus 2 is negative 2, and 0 minus 0 is 0. Okay, so you don't stop unless all the value of your CJ and minus CJ are all 0 and negative. If it is 0 and negative, then you already in the optimal column, optimal tableau, I mean. Okay, so the same as what you did in the first tableau, you get the optimal column, which is the highest positive CJ minus AJ. So you don't stop unless you all the value of CJ minus AJ are all negative and 0. In this tableau, we still have 1. And the same manner as what we did, the quantity should be the numerator, and then the intersectional element will be the denominator. So 18 divided by 0.05 and 15 divided by 0.5 and 18 divided by 3. So your replaced row will be SF because it's the lowest positive value, and then you'll have a new value of X2 and a new value of X1. If you try to look at the third tableau, all the CJ minus AJ are all 0 and negative. So meaning you already in the optimal column, and your decision will be seen in the quantity and product mix. If you try to look, your X1 should be 12, and you should produce also 6 of X2 to get a profit of 132. That's why your decision will be X1 is 12, X2 is equal to 6, and the total profit is 132. Okay, so if you have any question, you can PM me. Thank you.